So in the previous lecture, we have discussed about the basic properties of the flexible pavement and what are the different components of the flexible pavement. So in this class, we will discuss about the rigid pavement. So basically, as we have already discussed, rigid pavements are made up of the cementitious material as a binder. So rigid pavement have sufficient flexural strength to transmit the wheel load stress to a wider area below. So for this reason, generally rigid pavements are directly constructed over the compacted subgrade layer. Now, compared to flexible pavement, rigid pavements are placed either directly on the prepared subgrade or on a single layer of granular or stabilized material. You can directly put this over the subgrade layer, or in some cases, you can put some concrete layer or your yes concrete layer below the main rigid pavement layer. Now, since there is only one layer of material between the concrete and the subgrade, this layer can be called as base or sub-base course. So basically, this is a rigid pavement. Now, these rigid pavement are constructed by part, and therefore you need in some cases this type of reinforcement. And there are different names for these reinforcements. We'll discuss this later on. So generally, these are the layers of the rigid pavement: prepared subgrade, some drainage layer, it would be some concrete or aggregate layer, it would be some aggregate layer, then sub-base course, sometimes you can provide the sub-base course, then that rigid pavement portion. These are the different layers of the rigid pavement. Now, if you discussed about the characteristic of the rigid pavement, there are different characteristics. First one is rigidity. So rigidity is why it is called rigid pavement, because it doesn't deform under stress. For the flexible pavement, what happens? Suppose this is a flexible pavement and one wheel load is over this area. So after the applications of the load, it got deformed. Okay, it would be not such use, but it got deformed. Okay, so therefore that one was called flexible pavement because that was flexible, but in the rigid pavement it would have sufficient rigidity so not to deform under stresses. Then concrete, air entrained increase resistance to frost damages and de-icing salt corrosion. So you will use enough air entraining material in the preparations of the concrete so that it will be affected during the effective during the all weather condition. Now reinforcement, maybe bars or mesh. You can use some mesh or you can use some bars. Now continuous rigid pavements have heavy reinforcement. If it is the continuous one, in that case heavy reinforcement can be used. Now joints in the rigid pavements, joints is a very important part and parcels of the rigid pavement, because with the temperature changes, there are different stresses which will be evolved over the rigid pavement, and to relieve the stresses you need some joints. So you need to carefully design different joints of the rigid pavement. Now these are the components of the rigid pavement. Now there are two types of joint. One is longitudinal joints and another one is transverse or traverse joint. Now in these joints you need to use that reinforcement over there. Okay, so if we discuss about the reinforcement, these are the longitudinal joints and these are the transverse joints. And in the joints, transfer joints, sometimes you have to use the dowel bar so that stress can be easily transferred from one portion to the another portions, and in this portion you can use sometimes tie bars so that stress can be transferred easily. Now, if we discussed about the different layers of the rigid pavement, so first one is surface course. Now, this is the top layer which consists of PCC slab, that is plain concrete slab. It can be reinforced or continuously reinforced slab. Now, if it is continuously reinforced slab, in that case, the reinforcement would be higher than the normal reinforced sections. Now, it provides characteristics such as friction, smoothness, noise control, and drainage consideration. So, the pavement portion should be impermeable so that the water over there can be easily drained off and your subgrade can be protected. In addition, it serves as a waterproofing layer to the underlying base, subbase, or subgrade courses if you uses them. Now, the surface course can vary in thickness, but it usually between 150 mm to 300 mm. You need to remember this. The thickness of the surface course for the rigid pavement would be between 150 mm to 300 mm. Then base course. So this is the layer directly below to the PCC layer and generally consists of aggregates or stabilized subgrade. It provides additional load distribution, contributes to drainage and frost resistance, uniform support to the pavement, and a stable platform for construction of the above surface layer. Now, this base course is a choice if your subgrade course is not suitable enough or it cannot carry the load. In that case, you can use the base course. Now if your subgrade is okay, in that case, you can directly make the surface course over the subgrade course. Now, aggregate base, a simple base course of crushed aggregates has been a common option since the early 90s and is still appropriate in many situations. Basically, that is a choice situation. If you want to provide some aggregate base course in the rigid treatment, you can provide. Now, stabilized aggregate or soil. Now, stabilizing agents are used to bind otherwise loose particle to one another. If you want to stabilize the soil particle or soil subgrade, in that case, you can mix some chemicals so that this loose particle can be stabilized and act as a homogeneous mass. Now, cement treated bases can be built to as much as 20 to 25% of the surface core strength. So to stabilize this, you can sometimes use the cement slurry so that the entire subgrade portion can be stabilized so that a rigid surface course can be made over it. Now, dense graded hot mix asphalt in situations where high base stiffness is desired, base course can be constructed using a dense graded HMA layer. So, suppose in such cases where there would be chances of high loading, in that case, your base courses can be designed with a mixture of bituminous and concrete material, bituminous and aggregate material, and that is called hot mix asphalt, and above this you can build your rigid pavement surface course. In some cases for the drainage action you can also put permeable hot mix asphalt. So in certain situation where high base stiffness and excellent drainage is desired, in that case you can design for the permeable hot mix asphalt. If the drainage conditions you want for that site is higher. So basically dense graded HMA or permeable HMA, uses of these two HMA would be based on the requirement of the site. Then sub-base course, this is also a choice course. You can opt for the sub-base course if you feel it is required for the subgrade. So this is the layer under the base layer. A sub-base is not always needed and therefore may often be omitted. Now this sub-base course is the portion of the pavement structure between the base course and the subgrade. It functions primarily as a structural support, but it can also minimize the intrusions of fines from the subgrade in the pavement structure. So basically what does this indicate? It indicates that suppose this is a soil subgrade layer, okay, and over this you provide your base courses, and over this surface courses is there. Now load would be applied over there and it would be transmitted over a larger area through these base courses. So because of that load, sometimes what happens, the soil can penetrate through the base courses. Okay, soil can penetrate through the base courses. So to minimize the effect of this penetration of the soil into the base courses, sometimes you can provide one additional layer of the aggregates, okay, and that is called your subbase course. Now this subbase generally consists of lower quality materials than the base course but better than the subgrade soil. Appropriate materials are aggregates and high quality structural fill. Now there are different types of rigid pavement. First one is jointed plain concrete pavement, then jointed reinforced concrete pavement, continuous reinforced concrete pavement, and pre-stressed concrete pavement. So first one is jointed plain concrete pavement. So basically, as the name indicate, it would be plain PCC pavement, that is plain cement concrete pavement, and there would be some joints. So these are plain cement concrete pavements constructed with closely spaced contraction joint. Dowel bars or aggregate interlocks are normally used for load transfer across the joints, and they normally has a joint spacing of 5 to 10 meter. Then jointed reinforced concrete pavement. So here what happens, there would be joint in the surface course and there would be reinforcement. Now although reinforcement do not improve the structural capacity significantly, they can drastically increase the joint spacing to 10 to 30 meters. Okay, now dowel bars are required for load transfer and reinforcement help to keep the slabs together even after cracking. So if there are some cracking, then this reinforcement will help to keep all the slab together. Then composite pavements, it is a combination of hot mix asphalt and PCC pavement. So there would be one underneath base layer which is comprises of HMA hot mix asphalt, and over this one PCC pavement layer would be there. So as it is a combination of flexible type and rigid type, therefore it is called composite pavement. Now this difference is very important. Okay, that is difference between flexible and rigid pavement. So first one is flexible pavement. It consists of a series of layers with the highest quality materials at or near the surface of the pavement. Why highest quality materials? Because load will be distributed grain to grain and therefore the dispersion would be at a 45-degree angle and the area of the dispersion would be higher and the depth increases. Therefore the higher quality material should required on the top surface where the stress would be higher, and in the bottom portion the stress would be lower, therefore the some inferior quality material can be used. Then rigid pavement, it consists of one layer of Portland cement concrete slab or relatively high flexural strength. It reflects the deformation of subgrade and subsequent layers on the surface. It is able to bridge over localized failures in area of inadequate support. So what does this mean? It means that in the flexible type of pavement, if there are different layers. Okay, now if in the subgrade layer, if there is any damage, that damage would be gradually be seen over the top layer. It would be reflected throughout the layer. But in the rigid pavement, what happens if there is any damage to the subgrade layer, then the above surface of the PCC layer would act as a bridge over these portions, and this damage cannot be transferred over the layer. Its stability depends upon the aggregate interlock, particle friction and cohesion, because in the base course and sub-base course you are not using any of the adhesive materials or cementitious materials, and therefore its stability depends on the interlocking property. Therefore in the flexible pavement design, the grading of the aggregate is very important. Generally you have to use the well graded aggregate so that all the pores, okay, or all the gaps between the aggregate can be minimized. The structural strength is provided by the pavement slab itself and its beam action. Pavement design is greatly influenced by the subgrade strength. So as the subgrade is strong enough, in that case the pavement strength would be higher. If the subgrade is weak, in that case the pavement strength would be lower. Now here for the rigid pavement, the strength of the rigid pavement will be depending on the surface layer, which is made up of cement concrete. It functions by way of load distribution through the component layers by grain to grain, and it distributes load over a wide area of subgrade because of its rigidity and high modulus of elasticity. Now here, temperature variations due to change in atmospheric condition do not produce stresses in the flexible pavement, as it is flexible. Therefore there would be no temperature stresses developed over the flexible pavement. But for the rigid pavement, temperature plays very important role. Therefore you have to design different joints, and there will be some specification for the joint design and reinforcement provided over the joints. Flexible pavements have self-healing properties due to heavier wheel loads, are recoverable due to some extent. As it is flexible, so therefore any deformation caused to the flexible pavement, a part of the deformation can be recovered. Now in the rigid pavement, any excessive deformation occurring due to the heavier wheel loads are not recoverable, and that is, settlements are, whatever settlement is there, settlement is permanent. Another important thing is, for the flexible pavement, your initial cost of the construction would be lower than the rigid pavement, and the life of the flexible pavement is lower than the rigid pavement, and the maintenance for the flexible pavement would be higher than the rigid pavement. So short note on the rigid pavement, you can write it from over there. That is, in this thing you have to write out what are the different characteristics of the rigid pavement and what is rigid pavement. Then what are the different components of the rigid pavement. So here you have to write down different components like surface course, your base course, aggregate base, stabilized aggregate or soil, dense graded HMA, permeable HMA, sub-base course, etc. You have to write. And types of rigid pavement, these are the different types of rigid pavement which is discussed over there. And another important thing is, what are the difference between flexible pavement and rigid pavement, that is also very important. Is it clear? Okay, if it is clear, then you can leave the class. So ask your seer to ping me in the WhatsApp. I'll share all the PDF right from the class number 1.
Sampai
Dua account sih?
jelas
Saya kontak ya.
sekarang kita kurang nanti ini juga pak aku yang wajah itu sudah lebih tidak lebih harus juga nampak dari nanti ya bapak tangguh pak kucing itu saja
Enggak.
ini bisa anda follow dan lu kan sandin tak kolong ini